Welcome, ladies and gentlemen. So what I like to do is show you why you should never have to memorize the unit circle. So if you have a teacher or a friend or a parent that's saying you need to memorize the unit circle, please continue watching this video because I'm going to show you why you do not need to memorize this unit circle, as well as how you can actually solve some problems without having it memorized just as quick, or if not, quicker than people that have the unit circle memorized. So first of all, I remember when I first had to learn the unit circle and people were like, hey, memorize, that's the only way, you just have to memorize it, that's it. And it was confusing. That's just what I did. And I, kind of went through it and just blunt force memorized it based on all the angles and all the points and so forth. Then I got into teaching, and that's of course what I did. I just reiterated, you got to memorize it, you got to memorize it, you got to know these points. But the more and more I've taught and the more I've worked through the problems, I realized it's just a big waste of time. Not only is memorizing the unit circle confusing, you might memorize it for a couple weeks and then sure enough, 2 weeks later, you totally have forgot everything. But there's just so much information there and it's not even all required. The really only piece of information that you need to know from the unit circle is the first quadrant. Because if you know the first quadrant, as well as knowing what a reference angle is and a coterminal angle is, then you can solve you can evaluate any trigonometric function using the unit circle. It's much easier to memorize the first quadrant than to memorize the whole unit circle. So again, if you don't know what the reference and coterminal angle, I'll give you just a quick little definition, and then I'll kind of work through 3 problems showing you how I'd be able to do this. So on the reference angle is basically the angle, the acute positive angle between the terminal side of an angle and the x-axis. And the coterminal angle is an angle that has the exact same initial and terminal side. So usually if I give my students an angle like sine of 2 pi over 3, and they have the unit circle memorized, they can probably actually do this problem pretty quickly.
Campbell, please report to the main office.
Sorry, still teaching.
Campbell, please report to the main office.
So they could probably do this problem really quickly. But once I get to negative angles, or when I get to angles that are larger than 2 pi, that's where my kind of strategy starts beating them out, and it gets a little quicker. So again, 2 pi over 3, if somebody had the unit circle memorized, they would just simply find 2 pi over 3, which I had that erased, 2 pi over 3, and they say the sign, and they know that that is going to be square root of 3 over 2. And they'd kind of get that one covered, right? However, even using my system is not too bad, especially once you get a little bit more practice. So here's the way that I kind of break it down, so you can use it for future angles, as well as speed up the process. But I'm going to take it really slow just so I can explain it. So the first thing, if I'm graphing 2 pi over 3, I need to know where exactly 2 pi over 3 is. If I know that halfway around the circle is pi, well, here's pi over 3, 2 pi over 3, 3 pi over 3. So I'm traveling 2 pi over 3. That is my theta. That's my angle I'm given. The reference angle is going to be the angle from the terminal side. So actually, let's see. Here's my initial, and there's my terminal side. The reference angle is the angle to the x-axis to my terminal side. So if here's 2 pi over 3, halfway around the circle is 3 pi over 3, that means this distance is going to be pi over 3. Now I'm just going to write these out so we can just kind of keep track of everything. So that's pi over 3. Now I go to my first quadrant. What is the coordinate for pi over 3? So I go to pi over 3, and I can see the coordinate is going to be 1/2, comma, square root of 3 over 2. However, that is the coordinate in the first quadrant. I'm not looking for the coordinate in the first quadrant. I'm looking for the coordinate in the second quadrant. So it's important for me to know what's positive and negative in the second quadrant. And in the second quadrant, we know that the x is negative and the y is positive. Now let's just write it like this. Negative, positive. So knowing all of this information, I know that my point is, so pi over 3 and 2 pi over 3. And you can see, look at these 2 points. They are exactly the same. The only difference between the 2 points is the x coordinate is negative. So I just say, I'm going to use this point, I'm going to use that value, but I'm going to use the value in the second quadrant, which is still positive. So my answer is square root of 3 over 2. And again, I want to reiterate negative angles. If some of you had this memorized, usually the unit circle that people memorize is from standard position going in the positive direction. So all I need to do is give you a negative angle, and a lot of students have trouble because that's not the unit circle that they memorized. But if you know how to graph an angle, negative 5 pi over 4, again, remember, halfway around a circle is pi. So if we were to break this up into fourths, we would say that's 4 pi over 4. And again, remember, going negative direction is that way, right? Going in the clockwise is negative, counterclockwise is positive. Okay, so if going halfway around a circle is pi, that would be 4 pi over 4 if I was going to break that into fourths. But I want to go negative 5 pi over 4, so I need to go an extra pi over 4 up. Then, so that's where my angle, so here's my initial side. There's my terminal side. However, again, what we're looking for is that reference angle. What is going to be my reference angle? How far is it from my terminal side back to the x-axis? You can see here, I passed the x-axis. So I need to see how far is it to go back. So if here's 4 pi over 4, I went an extra pi over 4 next. That means all the reference angle is just taking me pi over 4 back to the x-axis. So I'll say my reference angle is going to equal pi over 4. That's important because now I need to go to my first quadrant and say, what is the coordinate for pi over 4? That's square root of 2 over 2. However, looking back at my angle, I see that it's in the second quadrant. Well, again, what is negative in the second quadrant? The x coordinate, right? So now the cosine, negative, positive. So cosine, again, represents the x coordinate, but since my angle lies in the second quadrant, my answer is going to be a negative square root of 2 over 2. All right, last but not least, let's go ahead and do a tangent problem. This tangent problem is 15 pi over 6. Now, one thing I want you to look at is when we have a coterminal angle, and I'll just kind of give you an example here. Here's an angle. If I take an angle and I draw the angle in the opposite direction, you can see that these two angles start at the same side, but they also end at the same side. Same thing, I could draw another angle and do an extra loop around the circle, and I would still start at the same side and end it at the same side. So those angles are coterminal. The difference is their measures, right? They have different measures. Even though they start and end at the same side, they have different measure. Well, what is the difference between their measures? Well, think about this. Think about these two blue. Think about our original and the one that I went around. I basically did the exact same angle, but then I did an extra revolution around the circle, which is basically adding 2 pi. And to get this first one, I'm basically subtracting 2 pi. So coterminal angles, the difference between coterminal angles is just plus or minus 2 pi. So if I had tangent of 15 pi over 6, the first thing I want to do is, well, let me find a coterminal angle then that's between 0 and 2 pi. So what I could do is I could rewrite this as 12 pi over 6 plus 3 pi over 6. Well, 12 pi over 6 is just 2 pi. That's just an extra revolution around the circle. So in reality, and then 3 pi over 6 really just gets reduced to pi halves. So in reality, I'm trying to find the tangent of pi over 2. Because the tangent of pi over 2 and the tangent of 15 pi over 6 are going to be the same because they're coterminal angles. They start and end at the same side. So again, I go to pi over 2. And this one, you're not going to need to know so much. You're just going to need to look at the quadrant that it lies in. The x-axis, pi over 2, is at 0, 1. So there is no reference angle in this case. So it would be 0, 1. Tangent is going to be y over x. So that would be 1 over 0, which is undefined. So there it goes, ladies and gentlemen. Please do not waste your time trying to memorize the unit circle. The best and easiest thing to do to evaluate trigonometric functions for given angles is to make sure you know the first quadrant. Memorize it, just do enough practice and you'll know it. And then use your reference and your coterminal angles to identify the point or the angle in the first quadrant. Then use your quadrants to identify if it's positive or negative, and then you're all set. And use coterminal angles to find angles between 0 and 2 pi. And again, I just want you to notice that the unit circle, all it is a reproduction of the first quadrant. When you flip it over here, the x is negative. When you flip it over here, the y coordinates are negative. When you flip it into the third quadrant, the x and y's are negative. But the main important thing is don't memorize the angles, because all I need to do is give you negative or coterminal angles, and it gets confusing. Just make sure you know how to graph any angle as well as find the coterminal and the reference. Thanks.